water. Of course, the oceans are much larger, and so we need many more comets to fill the oceans. But we're fortunate. We had many such comets in the early solar system, so we have every reason to believe that it was cometary delivery that brought water to the early Earth.
Muma thinks that the heat of an impact would have evaporated the ice within a comet, creating storm clouds over vast areas of the planet. These clouds produced a deluge of hot, possibly acidic rain that continued for millions of years. At first, the rain would have formed lakes and rivers, and eventually, water would cover almost the entire globe. But there's a problem with this theory. Earth's oceans contain a mixture of normal water, H2O, and a much smaller amount of a more exotic kind, known as HDO, or heavy water, which contains an extra neutron. In the comets analyzed so far, the proportions of these two kinds of water don't match the composition of water in our oceans.
They have twice the amount of heavy water that we see in Earth's oceans. So if they were the comets that delivered Earth's oceans, they wouldn't fit the bill, basically. They don't have the right properties.
But Muma hasn't given up. The comets already studied come from the outer reaches of the solar system. And he thinks comets originating closer to the sun might be different. Formed at higher temperatures, these comets could have a lower proportion of heavy water, more closely matching our oceans. And tonight, Muma hopes to test this idea by getting a first-hand look at one of these elusive comets.
If its chemistry is different, and if the heavy water to light water is like that on Earth, it would be the first proof positive, or the smoking gun evidence, that comets did in fact deliver water to the early Earth. That should be right, because it started bright.
It's very bright.
But first, the team has to hunt down the comet.
As soon as he has acquired it, we should see an image of it on this screen.
It's on the blue one.
There it is. All right. Yes, sir. Right there. You can see the elongated material flowing outward from the nucleus. Joel, that looks excellent.
With the comet in the crosshairs of their telescope, they can home in on the kind of water it's carrying.
Bring up the spectrograph.
Yeah. Moment of truth here.
Yeah.
Okay. People often ask, how can you measure water in an object that is 100 million miles away? We do this by a method called spectroscopy. It's a little bit like taking fingerprints. The little ridges on your fingers look different for every person. And in the same way, the light that is emitted by a given molecular compound is different. It emits at different wavelengths. Dark spot.
I think we just need more.
Let's do the long one.
It's this one, right?
But it turns out, this comet is a very dirty snowball indeed. There's so much dust on the surface that it can't reflect enough light for the team to find out what kind of water is on board.
It did not brighten as expected. This was a bit of a disappointment. Comets are quite fickle. You know, they're unpredictable. In some ways, they're like cats. They both have tails, and they both do what they want to.
But with astronomers finding 2 or 3 comets a year from the inner part of the solar system, Muma could soon have another chance to test his controversial ideas about the origin of Earth's oceans.
One of the key things that every scientist keeps in mind is you should never fall in love with your theory. So it's an idea, it's a hypothesis, it fits all the known facts, but it has not yet been proven. And we must be willing to give it up and modify it if it is not proven. But we will learn something in doing so.
It's still possible that comets played a role. In fact, it's hard to imagine that they played no role. But it seems more likely and more physically sensible to look closer to home for the source of the water.
Besieged by volcanoes and battered by impacts, Earth endured its most extreme punishment in its early years. It was beaten, bombarded, mangled, and melted, all in just the first hour of our 24-hour history of the planet. The young Earth was still very different from the planet we know today. It was a hostile and forbidding place, with an atmosphere full of poisonous gases. Yet somehow, these harsh conditions set the scene for a crucial phase of Earth's development: the origin of life.
Very little is left behind from the Earth's earliest time period, but what is left behind is revealed to us a planet much more complicated than we ever thought, with different rock types, liquid water present, and the kind of planet that we might expect life to emerge on. Do we know if life was around 4.3 billion years ago? Well, who can say? We can say, however, that the template, the ground underfoot, was there. Could life have been present? Why not?
But first, the once hellish Earth would have to undergo another change as radical as any that had come before. Catastrophe and cataclysm transformed the Earth. Now our planet would be ready for the greatest drama of all time: the rise of life.
Next on Origins, life takes hold on Earth.
Life evolved on this planet very early and very fast.
But where did it come from? And how did it survive in the hostile environment of early Earth? Go back in time to when invisible creatures ruled the planet and caused the most dramatic transformation ever in Earth's history. Watch the next episode of Origins.